as we said, this is slightly scary because it's TDD and the Terminator, an introduction to test-driven development. So a little bit about me. My name's Layla Porter. I am a director on the .NET Foundation. I'm a Microsoft MVP. I also organise my local MK.NET user group. I love C#, and I am a senior developer evangelist at a company called Twilio. This is me in Scotland with my dog Cookie, who's trying not to fall into the waterfall behind me. I'm happy she's not, so I thought it was quite a fun picture because I'm happy talking about the Terminator. Some people might not be. So you're probably wondering, the first question is why TDD and the Terminator? And that is a very good question. And this goes back to my job 2 jobs ago, and I was working still in telecommunications, and I was a senior software engineer at a telecommunications company, and I worked on quite low-level code managing, routing and rating for telephone calls to go through to different parts of the world, and allowed the people who operated those calls to set the prices and the routes they want to take. So quite complex. And this project I worked on, a big project, I want to ask you to guess how many tests this project had, but you can't because we're virtual. 0. Big fat 0, no tests whatsoever. We relied solely on a team of 6 testers, only one of which would write actual test code. The rest would be manually testing it. So going through and trying to think, oh, if I enter my name with, out any spaces or this and that, does it still work? That kind of manual testing. And it was after one particular release where we came back and there were 9 weeks to fix all of the regression bugs that we had made from the previous 18 months of code. We only released every 18 months. So there was a lot to go wrong there, but this was when I started to think, wow, 9 weeks for regression bugs, there has to be a better way. And I started to look into tests and unit tests, and that's when I came across test-driven development. And I thought, oh, this really interests me. This seems to work with how my brain works. So I tried to learn it. Now, trying to learn TDD is easier said than done. I really struggled. I watched videos and it just looked like magic. I watched I read books and went through blog posts and I just couldn't get it. And then I thought, right, I need to actually do some TDD. And I started a project, and I had recently watched Terminator 2, I think. Again, I'm a big fan of the Terminator movies, so I've seen them a lot. And I just watched it again and I was like, oh, I could program a Terminator. And that's what I did. And that was when I finally twigged how to do TDD. So I'm going to share with you that. It's gone through a few different iterations since then, and I'm just doing one quick thing there. Thank you. So let's have a quick think about what is good about TDD and why I decided it was a good way for me to work. And with that, I'm going to talk about the successes. Some of this will apply to unit tests, but unit tests are part of test-driven development. So let's have a look. Now, the first one is acceptance criteria. And this is where you go and speak to your project manager or your manager or the client and say, I really need to know the criteria that you will accept to say this code is done. And if they can't give you that, you don't write any code, because if you don't have a clear idea of what is acceptable, you can't write tests. So this means that there's no starting to code without a clear idea of how you're going to write that code. You know exactly what your code should do, and then you can go and do it. So that's a really important bit about acceptance criteria. Focus is the next one I want to talk about. Now, with test-driven development, you write just enough code to pass your test. Just enough. No more, no less, just enough code to pass the test, which I will demonstrate in a moment. And most developers, myself included, have ADHD, attention deficit hyperactivity disorder, or some form of that, where we're like, oh, I want to do this, but before I do this, I need to write this service, and before I do this service, I need to go and write this interface, and oh, before I do this interface, I need to re-architect the whole system, and you end up doing something that is often referred to as shaving the yak. I will post a link at the end of the talk explaining what shaving the yak is. So it helps you keep focus. You know that you just need to write enough code to pass a test. And that leads me on to interfaces. Now, I like to think of interfaces as a coding contract. I know exactly what my code should do because of the interface. I know the signature, and it doesn't really matter what the inside of that code is. Now, if I'm working with my teammate Clara and she wants to start on something that is going to use the code that I'm working on, I can give her the interface. I can give her that whole coding contract before I've even written any of the code that fulfills those interfaces. And she can start, because I will write tests that work with that interface, that coding contract, and I know that it's all going to work. No matter what my code works, I know it will work, and therefore it will work for my teammate, which allows us to develop asynchronously. Because you've probably looked at the backlog or the sprint and you're like, I'd like to do that particular unit of work, but it's dependent on this one. And Bob is writing that one, and I have to wait until he's finished, which could be 2 weeks' time. And sorry, my doorbell just went off. So it could be 2 weeks' time before that's finished. But if you have interfaces there, you can just continue without worry. So that leads me on to my next thing, cleaner code. Because you are just writing enough code to satisfy the tests and pass them, you don't have any of this extraneous code there. You can just write that little bit of code. You don't need all the other stuff. It keeps you focused. Nothing more is needed. And safe refactoring. This would have saved me 9 weeks of regression testing, because if we'd have had tests in place when I went or my whole team went and refactored the code, we would have known immediately that we'd broken some code. And that would have been really, really helpful in that situation. And this leads to fewer bugs because we can safely refactor the code. We're only writing enough code that we have. We're sharing the code. Everything's going really well. We don't have as many bugs, which is great, which leads to increasing returns, because if you're not fixing bugs all the time, you're writing new features, which is great for everybody. Everyone's really happy with that. And the last thing I'll say is that tests can become living documentation. They don't replace your documentation, but if you have a new starter, they can come in, look through your tests, understand what the code should or should not do, and then they can start to work on it immediately. They know exactly what's happening, and you can base your documentation off your tests. So it's a really useful thing to have. So let's go on to back to the Terminator. So how are we going to program our Terminator? The first thing we're going to do is the process. Now, remember that we wanted to do acceptance criteria. And what that means is we need to gather the requirements. So we're going to gather our requirements next. There are a few flashing images, just be warned. There are some flashing images in the next slide. Let's have a look. Well, we have 2 boys on a motorbike, and we are looking at the boys trying to identify them, and if they're positive, we're going to do something, in this case probably kill, and if they're negative, we'll move on. So we have a few things that we're doing here. So let's see what those are. Scan subjects and determine if they require further investigation, and investigate subjects of interest and determine if they are the target, and if so, terminate. So we have those things. So let's focus on this first one, which is scan subjects and determine if they require further investigation. I think that's a nice unit of work. Now, the key thing to do, TDD, is start with failing tests. This is really, really important. If your tests are passing before you've even started, something's gone wrong, and we'll come back to that in a little bit. Because let's think about if you've written code already, and this is one of the greatest things about TDD, I think. Some people say, why TDD and not just unit testing? And this is why. When you write tests after coding, you may be writing them to fit your code and not your requirements. And I think this is a key understanding of test-driven development. For example, I have an API endpoint, and this endpoint returns a 200. And so I now go and write a test that goes, return type should be 200. Return type HTTP status should be 200. Yay, my tests pass. Amazing. But if I really go and look at my documentation, which I looked at that a few weeks ago and I've forgotten it, it actually wants me to return a 203, like no content. And so I've actually not fulfilled my requirements. And so is it 203 or is it 204? My brain's gone blank. Anyway, it returns a different status code and no content. So this is why I like test-driven development over unit testing, because of this reason. I like to use something called the red-green refactor pattern. And this is where you start with a failing test. You write just enough code to get the test to pass, and then refactor. So this is clean code, and that focus, it encompasses it all in here. So I think we should go over to code and have a little look at this in practice. So over here, I have a .NET Core project, and it started already. So I have an interface for something called a iSubject, which has a property called subject name. And I have an implementation of that, which is public string subject name. I also have this service called an iSubject analyzer, which has this method, which will return a bool, and it takes that iSubject. And then I have my test class. So if I just zoom in here, I use NUnit for my testing framework. It's my preferred one, but you can use XUnit, Windows, whatever you like. They're all very similar. I just happen to like NUnit. So first thing we need to do is identify what we're testing here. And we're going to be testing iSubject Analyzer. Now, I would generally like to call that SUT for subject under test, because you may have other services and things in here, and it can get confusing when you're writing code. Which one am I testing again? So it's good practice just to say SUT, subject under test, this is what I'm testing. Now, NUnit allows you to do some setup, and then we'll write our class, our test methods down below. So our setup is going to be to initialize SUT. And remember, this is an iSubject analyzer, and I do have something over here already, which is called subject analyzer. So let me grab that, and we're going to have a new one of those. Okay, so that works fine. And we now can go and write our first tests. And this is going to be, actually, let's go over here. You saw that everything has a big red line through it, and that's because we haven't implemented this interface. You need to fulfill the coding contract. So if I click this red thing, I can implement missing members. Let me zoom out a little bit, and you can see it's brought in our bool investigate further, and it's now just got a throw new system not implemented exception. We'll leave that there. This is perfect to write our tests to. So if we come back over here, I am going to come in and I am going to write a test. So these are just little decorators that we use inside with NUnit. So this is going to be a public void, and we're going to say Terminator should, oh, if I could type, determine to, let's say, investigate a woman. We're going to look for Sarah Connor. Investigate woman further. Okay, so the first thing that you need to do in your test is think about what you're going to do, and that is arrange, act, and assert. Okay, these are the 3 steps that you do in a test method. Let's have a look at our act, and this is going to be var result is equal to SUT. Let me make that a little bit bigger for you. SUT, and the method we're going to test is investigate further. So we're going to say investigate, but this is expecting an I subject. So this is where the arrange comes in. We're going to say var subject is equal to a new subject, and I'm going to instantiate that with subject name equal to woman. And yes, oh, I've switched from my PC to my Mac, so I keep using the wrong keys because I've got a PC keyboard. And now we can pop in woman as our subject here. Okay, now to assert, we're going to say, and I'm going to use something called Fluent Assertions. It's just a nice little library that allows you to write code like this. So .b true. So it writes it in plain English, which is quite nice. And we can come over here and run our tests. So if we run it, remember we want to start with a failing test. And where are my test? Oh, there it is. It's hidden down here. I was like, where's my test explorer? Here we go. So you can see, as expected, it has failed. So let's go and have a look at this. Now, let me just retype. It should be true. So what do you all think the least amount of code I can write here to fulfill our test? Remember, that's all we want to do, the minimum amount of code to pass our test. Well, I'll put you out of your misery. It's just return true. So I can also run my tests from down here. So if I press play, it's going to run it. Looking positive. Yes, it's green. Awesome. So we've done that. And that's it. That was a big aha moment for me. Let's go and write another one. Let's see. Let's say, oh, doing the wrong commands here. Command copy, Layla, and paste. So this one is going to be should determine not, because let's say there's a T1000 from T2, Terminator 2. We're all on the same team, so we just can ignore them, and we don't want to investigate a T1000 any further. So down here, all I need to do is say false. And let's run this test. And if we look down at our test explorer, oh, it's failed. Well, we expect that too. So let's go and write the least amount of code to get it to pass. So let me copy this. Let's go if subject.subject name is equal to woman. Did it again. Woman. Return true. See, I keep doing it. There we go. Otherwise, return false. Okay, so one word of caution here. Do not program killer robots based on string matching. Promise me you won't go and program killer robots like this, okay? This is purely for demonstration purposes. Now, let's go and run all of our tests again. If I click run, because I've changed the code, I want to run the first test again to make sure it's passing. And you can see all of my tests are passing. This is great. But now, what if I want to go and investigate a boy, John Connor? Well, do I go and write yet another test? That's going to be a bit repetitive. So what we can do is use something called a test case. And this is a little bit like a tuple. What we're going to say is we want to pass in a woman. And here we'll take the woman out of here because we're going to just make this a little bit more generic. And we're going to say we're going to pass in a string called subject name. And then we'll replace woman down here with that. So if we come down and do that, you can see that. Now, when I want to add another case, I can go boy. Now, what you'll see down here in the analyzer, in case you're wondering, I'm using JetBrains Rider. So this is very similar to ReSharper's test suite. You can see now I have 2 tests. It's expanded out these test cases for boy and woman. So let's go, and if I pop this here, let's run all tests. And I'm expecting the new case, this one, to fail. And it has. Women still passes. So let's just go and fix that quickly. And I'm going to do a really horrible bit of code, people. Let's go and change this to boy. Now I've done that. Least amount of code, remember, to get it to pass. And we'll run all of our tests. Hurrah! It's all passed. So there you can see how you can start to go through the red, green refactor to start your code. So let's go back over to the slides. And let's think about the refactor. The project manager is going to tell us to do something in a minute, but let's start with a nice bit of refactor here. So we have investigate further method, and I now have all of these ifs. Ugh, it's not very nice, is it? So let's refactor that into a switch. It's not a fancy new C# 8 switch, or C# 9 now, we're well past C# 8. It's just a regular switch. And that's a nice way to start. And you can see I've got all of my test case here, and we've got all of those going in here. And the test cases match the switch quite well. So we can see here that T1000 is going to return false, or anything like that is going to return false. So we're good. But those pesky product managers have a requirement change. So we're going to watch another clip now. There's a little bit of flashing there just to warn you. So we have a Terminator, and that's Sarah Connor and John Connor. They're doing something to the Terminator's chip. So they've changed something. He's learning things. Interesting. So we've got some new requirements. Protect John and Sarah Connor from threats and the ability to learn. Now, just before I continue, I want to know if there are any Terminator movie buffs out there. The scene you saw with the chip being removed is only available in the director's cut. So if you've seen that, you can be in my Terminator fan club. If you haven't, go and watch the director's cut. So let's go on and let's have a look at our code, because we're about to break it. We have our switch case, everything's passing. We're saying if we see a T1000, we're not interested here, but what if I change my code now? Because we are interested in T1000s because they're a threat. We need to go and investigate them and get rid of them because they could hurt John and Sarah. But now the expected result to be false, but it's true. So what are we going to do? So this is where designing your application to be more robust is a really good idea. And a way of doing that is through design patterns. Now, anyone who's looked at my Twitter profile will know I'm very into solid principles. I won't bore you about solid principles too much. That's a whole different talk. But we're going to touch on the ones that seem very applicable to test-driven development. So this is what the solid principles look like. We have single responsibility, open close, list of substitution, interface segregation, and dependency inversion. We want to focus on the top three, as I like to call it, the sunny ones for Sol. And let's have a closer look at these. So the single responsibility means that every class or module in a program should have responsibility for just a single piece of that program's functionality. And open close, software entities, classes, modules, functions, etc. should be open for extension but closed for modification. And list of substitution, objects should be replaceable with instances of their subtypes without altering the correctness of that program. So we've already kind of got list of substitution there because we're working with interfaces. We can have any implementation and our test should still pass because we test the interfaces. Okay. We also had the single responsibility. That's keeping our focus. And just a point, I have seen code controllers in like an MVC application where one controller method had over 800 lines of code. And this was why we had so many regression bugs. You don't know what you're breaking when you fiddle with that. So it's really important to adhere to these principles within reason. And we'll get to that. Now, the open close principle. When I first read that, I was like, I don't understand what this means. What is it? What is it? So I'm going to show you a little example of that. So let's go and see these in action. So we'll refactor. This is what we have at the moment. Now, the first thing I want to do is just tidy up our tests a little bit. So they're going to get a little bit more robust. And what we'll do is change them. So we're going to delete the negative one down here, and we're going to have a test case with an extra value in here. And let's just go through. If we look, we have a test case that has woman and true, and you can see that's subject name and outcome, which is a bool. And then just as before, we have the subject name is equal to subject name, and we've changed the result down here. It was result.should be true or be false. We've just changed that to equals whatever the outcome is, okay? Because we know that this is going to be returning a bool. This var here is a bool, so if it matches, it passes. So by doing this, all of our tests pass. So we're happy. Before we start, we've done a nice little refactor of our tests before we even start. Okay, so let's have a reminder of what we have. We have something called iSubject, and we have its implementation, and then we have this switch case over here. Now, what I'm proposing is we're going to use a rule set, and this is a really nice pattern to do, and it really shows the open-close principle in a nice manner. So this has two methods. One is called isMatch, and that takes the subject and returns a bool. And the other one is of interest and also returns a bool. And let's see how we implement those subject rules. And we'll do it by looking at the switch case. So the first case we have is woman. So we're going to create an isWoman rule. And is a woman of interest to us? Do we want to go and investigate further? Yes, we do. So this one should return true. And then we just need to do a little check to say, is this subject the subject that we're talking about? So we have an isMatch rule where we pass in the subject, and it will return true if this subject name is woman and false if not. So it again is just like, oh, is this a woman you're talking about? Well, then you need to use this isWoman rule. Let's have a look at another one, an isDog rule. Well, that one's going to return false, and you can see here it will match and return true if it's a dog. Remember, don't build killer robots based on string matching. But in all honesty, this here, you could have any implementation here. You could go and take use computer vision, for example, and do some certainty on computer vision coming in here, but it's not going to change the overall code. You'll change subject, you'll change the innards of this code, but it won't change anything elsewhere. The signature will still be the same. So this is still quite valid. So this is what our investigate further method becomes. I've put it all in the complete class so you can see. Obviously, this is just the method without the class. And we're going to step through this. So if we have our two rules, women rule and dog rule up, let's see how we've used these to implement our interface. So the very first thing we want is a collection of I subject rule. So notice this is a collection of the interface, not an implementation. That's really important here. And we'll just call this one subject rules. I've added a constructor here as well because we want to instantiate our collection. And you can totally instantiate a collection of interfaces. Now we're going to add our rule sets, and because both of these fulfill I subject rule, we can add them to the collection. And this is an example of sort of Liskov substitution. It doesn't matter which one we do, it's whatever the implementation of that interface is, we can put in here, okay? And it's going to work. And then we've got our is woman rule and our is dog rule, as you can see there. Now, the signature of our investigate further hasn't changed, but the insides have. And what we'll do now is we're going to loop over this collection and we're going to call on the first one where when we call this is match method returns true. So if we have a woman passed in as the subject, when this loops over using a little bit of link here and it gets to the is woman rule, it's going to return true, and we know that's our rule. And then we pass that rule into this little private method which calls the rule dot of interest. If you remember, when we call that, it's just going to return true or false, so we know whether we want to investigate further. So it's a little bit more code, but it's much more easy to maintain, and I'll show you why in a moment. But I just want to draw your attention to this private method. If you need to make a private method public in order to test it, then it's time to refactor. Remember I gave my interface to Clara and she's been writing her code. If I go and make that method public, I need to then add it to the interface. And that's not great because Clara doesn't need it. I just need it to test this little bit of code here as a little function specifically to my use case, but Clara doesn't need it. So there may be that you don't need to test it. I don't need to test that little private method there. There's no reason for me to have to write a test for that. But if you did have something you wanted to test, you don't really want to end up with Clara having to throw this. This is a real code smell, as they say. I've seen implementations of interfaces with like 30 of these implemented methods with throw new not implemented exception, and don't do it. Do this instead. Interface segregation principle. This splits interfaces that are very large into smaller and more specific ones so that implementations will only have to know about the methods that are of interest to them, because you can implement multiple interfaces. So use it. If you need to make it public, create a new interface for it and only implement in your code the two interfaces. Then Clara never need know about your public method there because it's handled by a different interface and you would test that interface in a different test class. So let's have a look. We have this code here, and when I run all my tests, everything still passes. So we know that this has all worked. So let's go and have a look at them side by side. I said this was going to show you the open close principle, and it does. How do I add new things to this? How do I modify it? But remember, it's closed for modification, but only open to extension. Well, I'll create a new rule, and that rule I can just add to the collection in the constructor. It doesn't change any code. It's extended the code, but we haven't modified anything here, and I can keep adding them and adding them. So you can see we've not changed the code, but now we're including all of these rules. So if you're working in something that you know, like notifications is a really good way of using this rule set. If you have a loop where you want to go over what type of notification should I send to a customer, a rule set is great, and I use that for notification services. I will have each type of notification as a rule, and I'll loop through them and do the notification that's relevant at that time. So with good practices, code management becomes infinitely easier because I don't have to go and fiddle with my code. I just go and extend it in a manageable way. But let's have a think about how TDD fails. And this is more how it fails in the workplace when you're trying to learn it. And the first one is underestimating the learning curve. Many people are like, oh, I can just learn it. But when they come to actually learn it, they're like, whoa, this is hurting my head. Of course, there's always some people who are like, yeah, got it. You know, that's great for them. But like me, I was like, I don't know how to do this. I can't understand how to make the magic happen. Lots of people confuse TDD with unit testing. I did a Twitter poll and I said, who does TDD on something or other? And people go, oh yeah, I write unit tests. I'm like, yeah, but that's not TDD. That like, oh yeah, but I write unit tests afterwards. I've done test-driven development. They don't understand that you have to write the tests first. Thinking TDD is enough. No, you need integration testing. You need user acceptance testing. You need to test your own work. It's just another factor that helps with better maintainability. Not starting with failing tests, that should make you think, hang on a minute, have I written too much code? Have I not fulfilled my requirements? What's happened here? And not refactoring enough. So adding extra methods into interfaces, etc. Okay, so if you're doing any of these, you're not actually doing TDD really, so a lot of people aren't doing it. But let's think about how we would implement this in an organization. It can be controversial and it is a significant culture change. Many people always ask me, oh, how do I get my team doing TDD? You know, we want to start on our next project. It's not something that you can just start. I take a very pragmatic approach to TDD. And so with my approach, you can softly transition over to it. A lot of people only want to do the dogmatic way. I've had people come up to me, my team lead, say, you didn't write everything here TDD, you didn't write your tests first all the way through here. I'm going to delete your day's code. That doesn't help anybody. That just left me feeling like, oh, but I was trying. I was learning how to do TDD and I did most of it TDD. That's quite difficult. So it can be quite controversial and it is a significant culture change. There is an initial drop in productivity that can be disconcerting. If you have a very productive team and you slow them right down to you start thinking about how to do test-driven development, there's a big foundation that you have to do. You have to totally turn the way of working around. So there's this big drop. And you need to prepare project managers for this, clients for this, your team for this. They need to know that it's okay that productivity drops. That's really important because once the foundation is in, productivity will just go up and reworks will be reduced. So in the long term, you're not accruing technical debt. You're keeping everything, you're putting in a lot of foundational work, and you don't have to worry about accruing all of this debt and refactors later down. You do get an increased understanding of requirements and their acceptance criteria, which is great for wayward project managers who are like, oh, just figure it out. No, you need to think about what it is you want, and then the team can write code tests for it and produce the code that will fulfill your needs. So it's you definitely get an increased understanding of requirements all around. So I want you just to take one thing away from this talk, hopefully more things, but if you do just take one, it was my aha moment to write the least amount of code, and if that needs to just be return true, then just return true. Okay, that was a huge thing for me. So just write the least amount of code to get your test to pass, and that should set you on a good path forward. So with that, I'd like to say thank you. You can find me in the following places: on Twitter at Layla Codeset, GitHub Layla-P. You can email me there. This repo is available on bit.ly TDD-Terminator. The deck is also available on TDD-deck. I am on Twitch several times a week, so you can always find me on Twitch. I have been doing a lot with identity recently, so you can come and find me on Layla Codeset. I've also been doing Blazor. We'll probably be doing Blazor tomorrow. And remember, I said if you wanted to know more about what shaving a yak is, you could go to Yak's bit.ly shaving-a-yak, which I think will make you laugh. So yeah, thank you so much for listening, and maybe there are some questions, we shall see. So let me stop sharing. Oh, I see you two are back. Hang on, let me stop my screen share.
Yes, we're here. Thank you so much.
You're very welcome.
It's been encouraging. So TDD is not dead, right?
Say that again. What?
So
What's TDD?
It's been encouraging. So TDD is not dead.
No, it's not. It's not.
It's not that. It's just to be learned and just to be applied, and we need to grow our skills.
Yes.
So nothing to be scared of.
No.
Right, Benny?
Yeah, and I like this presentation a lot. Plus, I think I resonate a lot with your conclusions, Layla, or especially when you talked about why TDD fails or it discourages some people. And for instance, with respect to this in unit testing, I always say, yeah, you can achieve code coverage with tests with other means, but the real value of TDD is the fact that allows you to grow a better software design.
Yes.
And the test coverage comes second.
Yeah, test coverage. For those who don't know, test coverage is something you can put on your build server or your repo, that every time you commit to your repo, you have to be increasing the percentage you have of code, of tests, not decreasing it. And that can be quite difficult as well, because you don't want to test everything. And this is my practical approach to TDD. There are things that you just don't want to write unit tests for, like data repositories. Nobody wants to write, unit tests for that. And you might want to write a integration test for that, or do something else. So I know there are a lot of people who've spoken to me after this talk and go, "You're doing TDD wrong, Layla." And I'm like, "Oh, really? Well, you start with interfaces." And I'm like, it's because I do it from pragmatic side, and there are those that do it dogmatic, really stick to the rules, and that's okay too. But that way doesn't work for me. I think you need to be flexible. Software and teams and people aren't regimented. And I think if you, it's much better adoption within a team if you're slightly flexible.
Indeed, because I've been having a lot of talks, I think even this year, with a lot of, let's say, convinced or TDD practitioners, and they all say that, yeah, you need to understand all these flavors and approaches, and in the end, find your own way and see what works best for you.
Yeah, absolutely.
We've got a specific question
Okay.
related to your presentation. Somewhere in the code that you've shown, someone is saying that you possibly broke the D from solid. You know.
Oh, really?
I don't know. But I think this will trigger a conversation between maybe you and the person who asked that.
Anonymous person.
Right.
So added a new X. There's a thing about it's not breaking that rule, it's a principle. The solids are principles, not rules. So when I extended the rules, I'm adding new X, I didn't create a dependency as such. I was extending the code. Now, I did do that in the constructor. You could, because it's easier to demonstrate, you can take that whole list out and make that inject that as well. So if I was writing that, there's a way that you can scrape through everything in your startup. You can go through, scrape through. If that person wants to reach out, I can give you a GitHub repo where I do this. And you can go in your startup, loop through everything that implements that rule, add it to a collection and inject that collection. So the fact that I showed it in the constructor was for simplicity. It does kind of create a dependency, but it doesn't have to. You can inject it. So yeah.
All right. So I'm kind of changing a bit the topic here because I'm being selfish, to be honest. So you're working with Twilio, right?
Yes.
Okay, so we've been recently doing some projects because, well, 2020 seems to be, the trigger of communication platforms related projects, right? And we're doing some projects in this space, and we've been playing a little bit with other platforms like Dolby.io or similar things. What would you advise? Should we try Twilio? We've evaluated.
Okay.
Okay,
Well,
and it's a brilliant platform, of course. For the time being, we've been choosing another one, but I think we've already started to think back on Twilio, But anyways, how Twilio these days?
Reach out to me, Florian, and we can have a chat because it depends on your use case. And some people, they might want to go for a cheaper option. It depends, if Twilio suits your needs. So yeah, we can have a chat.
Okay, let's do that. I'm definitely interested. But how is, by the way, 2020 for a company which is creating communication platforms?
It's been a boomer year. So we have been very successful this year. We've had huge growth because we have a contact center product called Flex. So it's all written in React. So don't ask me anything about it because I'm useless with React. I've had multiple training courses on React and it's too functional. My brain is very object orientated and functional programming is like, so we had a contact center product and lots of companies now, because people can't come into the shops, they need call centers and things like that. So I guess we had the right product at the right time. So it's been quite good from that respect. And I already worked from home, so nothing really changed for me.
All right, good.
Yeah, same here. Apart from the fact that it was nice to know you're able to work from home, now you have to work from home. I think that's the only difference for me as well.
Definitely. It does change a little bit around that. Yeah, you can. It was nice occasionally to go to the office, although it takes me over an hour to get to the Twilio office because it's in London and I don't live in London. So, oh my goodness, it's John Galloway. Can I just say that John Galloway is my hero. He does know this. He is my hero.
Layla, that was one of the highlights of the past few years, is meeting and talking to you about that. That was That was great. No. I don't know if I joined the wrong meeting. I was.
No, you're in the right place.
It's the perfect meeting.
The perfect meeting, and
Yeah.
So we very much enjoy this, you know, the interaction that happens during the supposed break when one speaker prepares to leave the stage and the other prepares to enter the stage, and we have this conversation. It's lovely.
Yeah, especially when we all know each other and.
Yeah.
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 Because this is the time when you can like make plans for the next year, maybe to meet in person, because we are discussing about working remotely and so on. But let's start to make some plans to travel, right?
I can't wait. I really can't wait.
Codecamp is here for you. We can't wait to have you in Romania.
Yeah. I mean, I had a great time. I went to Yash last year. It's all a blur now, but and that was great. And I'd be happy to come back to Romania.
Yeah. I've never been, so I want to come. So
okay.
Yeah.
Sounds like a plan. Sounds like a plan. Thank you so much, Layla. Yeah. Thank you so much. And until next time, see you in Ash next time, or Cluj, or Bucharest, or Timișoara, right?
Absolutely, and nice to say hello to you, John, and have a good session. And thank you so much, everybody, for having me. Cheerio.
Thank you.
Bye.